All right, so we've got to write down the equation of the tangent to this parabola. So we've got some sort of parabola, and we've got some equations of tangent. So let's say here's a tangent. Whoops, very straight tangent at the point P. Okay, where x is t, so it's t something. Of course, when I put t into here, I get, oops, if I move it across a bit, I can write the y in there as well. Okay, so when I sub t in, I get a t squared plus bt plus c for my y-intercept. It's for my y, sorry, my y value of that point. Okay, and so we're writing down the equation of the tangent to that parabola and then doing something else to it. Okay, so let's write down the equation of the tangent to that parabola. Okay, so we've got a point, there's our point, and we need a gradient. So let's have a look at the gradient. If we want the gradient, we want the gradient function first. So to find that gradient function, we differentiate. And if we want the gradient at, so the gradient, I should say, at x equals t, what is the gradient? And the gradient would be sub in t, so 2at plus b. So that's our gradient, and we've got our point over there. So if I use the point gradient formula, we're getting y minus y1 at squared plus bt plus c equals gradient, that big thing, x minus the x value, which is t. So that's the equation of my tangent. If I simplify a little bit, let's expand these brackets here. So I got 2atx, I've got a bx, I've got a minus 2at squared, I've got a a minus bt, so let me change that. I've got a minus bt there, and I'm going to add this here, so I'm going to add at squared, a bt and a c, and you'll note that bt and minus bt cancel. We've got some at squareds that go together there, so let's do the x's first. So 2at plus b, lots of x's, because of course that was the gradient. And then what's left is minus 1at squared plus c. So you can see this is the equation of the tangent here. So here's our equation of our tangent. Got it? And we want to, so the second part, so that was the first part of the question there, and show that the condition for the tangent to pass at P to pass through the origin is that. Okay, so it talks about this passing through the origin. Okay, so let me make it pass through the origin. So let's say the origin is here. I should have made it further over. Anyway, doesn't matter. Let's say that's the x-axis and it passes through x, y, there we go, it passes through the origin. So clearly it has to pass through 0, 0. Well, let's make it pass through 0, 0. So 0, 0, bracket, minus at squared plus c. So that's all 0 as well, because 0 times anything is 0. So if I put at squared on the other side, I get c equals at squared. Or another way of saying that, of course, because this was a show that it's at squared minus c equals 0. So we've shown that if this tangent is at P is to pass through the origin, then at squared minus c has to equal 0. All right, and there's a bit more. Hence, find the conditions on ABC for such tangents to exist and find the equations of these tangents. So we've got this tangent equation in yellow, and we also know that at squared equals c. Okay, I'm writing it that way because I like it that way better. Okay, so let's put that into what we've got already. So we can do this a number of different ways, but if you just have a look at this, t squared is positive, so if a is positive, then c would have to be positive, okay? Or if a was negative, c would have to be negative. So a and c have to both be positive or both be negative. All good. All right, now if I look at what t is, so clearly I can take that and go, well, t squared is equal to c on a. I'm going to go ahead with the fact that both my a and c are going to be positive because I'm going to need to square root them. Oh, it doesn't matter because if they're both negative, negative divided by negative is positive. Perfect. All right, so that's got to be positive because when we square root, we're going to get both plus and minus c on a. Okay, so that's what I'm going to use to find my actual equation. So you can see these equations have t in them, and we don't want the t in them. Okay, that's really what this question is saying, get rid of t. Hence, find the condition on ABC for the tangent to exist and the equations of these tangents. So we found the condition. What's the equation of these tangents? Okay, so let's have a look. So we're going to have y equals x. Now this is going to be 2a, I might just do it down here, 2at, now t, let's do the positives first, would be that, wouldn't it? And if you think about it, that's a to the power of 1, whereas this a here is under a square root, so it's a to the power of a half at the bottom. So another way of saying that is 2a, c is to the power of a half, and a is to the power of a half at the bottom. So we can see that we can cancel a half and just get a half at the top for a. So hopefully you can understand that that will be simplify to 2 square root ac. So that's what I'm going to put up here. So it was 2at, so it becomes 2 square root ac plus b minus a. Now it's a times t squared, which is, of course, c, because at squared is c. And we're going to get, of course, minus c plus c, which is 0. So, yeah, of course, otherwise it's not going to go through 0, 0. It will have a y-intercept that's not 0. But we want a y-intercept that's 0. We want it to go through 0, 0. So, therefore, that is your one of the tangent equations. What's the other tangent equation? Well, that's when we sub in our negative here, like a negative square root instead, right, the negative version. So we're going to get negative 2 root ac. So it's going to be y equals x, and it's going to be negative 2 root ac plus b. Okay, so they're going to be our two different tangent equations. Let's check what the question asked for, hence find the condition for such tangent and the equations of these tangents. So there's the equations of those tangents. Okay, so you've got the equations of those tangents.